Okay, welcome back. This should be the last and final video here, just doing our last kind of practice problem on linear functions and how to contextualize things. Um, so take a look here. This is just our last problem that we have to do, number two. And if you're following along, this is just coming back from the notes from before. Oh, I think this was, gosh, we did a warm up so far. Sorry, I'm going kind of far fast. And group exercises one, group exercises two. And at the end of this, I'll give you guys some problems you can practice and hopefully complete and turn into. So take a look. There's a model of graph, and that's going to be a model used by healthcare providers for finding ideal weight from a given height. So ideal weight from a given height. And notice the graph is labeled. I don't have anything for certain parts of the graph, but it looks like I have spots. And notice it always helps to kind of go through. And I have one here at, oh, what's that? That spot is 60 comma 100. And pick another nice spot. I always try to do that. You could do up here. I can do in the middle here too at 70. So always pick two nice spots. And I could have picked the other one too. It's all dependent on personal choice. We'll call that one 70 comma what, 150. Okay, and right off the bat, um, we're going to define our variables again from the last video. Sometimes that's further down, but check out B again. X is going to be height in this case, and that's because this is the x-axis. Okay, that's how they set it up, and this is the y-axis. So because they did it this way right now, and how y always depends on x, and in this case y was weight. Don't forget it's in inches and in pounds. So in this case, because y always depends on x to be a function, remember for definition of a function, for y to be a function of x, memorize this thing. For every x, there's always one y. So for this, for every weight, for weight to be a function of height, for every height, somebody's going to have a certain weight. Now that's all because of how they set it up in the graph. A lot of times they're giving, or the problems will give you subtle directions without saying anything. This is always the independent, the x-axis. Sorry for the handwriting. And the y-axis is always the dependent variable. Okay, so y always depends on x. So in this case, we're going to say health care providers think that the weight is dependent on how tall you are. And that might not be the case for everybody, right? So you might have somebody that's really skinny or very large if they're small. Same thing if you're tall. But I would venture to say that on average, and notice on average with the constant average rate of change, if you're using a linear model to predict stuff, that Shaquille O'Neal, who's like 7 foot tall, would probably on average, a 7 foot person would on average weigh more than somebody, oh, 60 inches. And remember, inches, there's 12 inches in a foot. So we're talking about 5 feet at 60 inches. So let's go ahead and take a look at the problem and see what they're asking. So why would healthcare professionals develop a model that correlates height and weight? And really, that's so open-ended. As long as you could defend the question on an exam or a midterm or a quiz, I'd have to go ahead and take it. Some possible, I'm just thinking of ideas off the top of my head, and I won't write this down, but you can. I might need a model like that. For instance, gosh, let's say you were going in and having surgery. Surgeons and anesthesiologists use charts and formulas like this to model how much medication they have to give certain people based on their height and weight. So, I mean, there's one example. Why would they develop a model? So that they, and really I might say, so that they can make future predictions about whatever they need to do. In other words, whether it's medicine, somebody that's bigger will need more medicine than somebody that's smaller, and so forth. So hopefully you understand what I'm trying to communicate there. And again, if I were going to give an exact answer, why would they develop a model? So that they can make decisions based on people's or person's weight or height, knowing one without the other. That's probably what I would say. Now, down in part C, do you think the model represents males and females? And do you think it represents adults of all nationalities? Now, in some instances, I don't know. You could always find exceptions to any rule, but there's nothing having to do with anything national, or excuse me, with the nationality. So I don't think you could say it represents anything to do with nationalities. Certainly, there are healthier people in different countries. But do you think it represents males and females? And again, it's so open ended that you can probably say whatever you think. You could say, well, a person 5 feet tall, which is 60 inches, and I'm looking at this first point here. In general, you could make an argument and say, well, I think it represents females because in general, 100 pounds for a female 5 feet tall sounds more reasonable, as a male might weigh a little bit more. Or you could flip it and completely go the other way with it and say, no, there's no data given to distinguish between one or the other. Maybe this is just an average of that average. So again, when you have these open-ended questions, it's really the question is you're trying to determine, do you understand what's going on, not necessarily looking for a particular answer, if that makes sense. So you could say, I might say in this one, I don't have a way to tell if it's male or female either. So in this case, I would use those explanations and say no in both cases. Now, here we go. Find an algebraic model for the relationship between weight and height. Now, we already defined our variables precisely. And what frame of reference for inputs might save you some time? We're going to say my frame of reference that for my data that we're only going to do or talk about people with a height from 60, say to about 83. We're going to estimate that. So, two questions here to answer. Find an algebraic model. So that's code for find this function again, y equals mx plus b. Okay, and let's go ahead and do that, and then we'll answer the second part of that. But we already defined our variables, and I know I'm writing up top here, but remember, my slope is defined to be y2 minus y1 over x1, and all you need are 2 points. So if I need 2 points, do I have 2 points? And if you look up, I sure do. And notice the more accurate you can be, the better your answers will be. So that's why I picked them on kind of the crosshairs, the easy to read part of the problem. So 6100 was 1 point, and 7150, let me make sure everything matters on that, is the other point. And because we're assuming a linear rate of change or an average rate of change, my answers should also work if you had picked this additional point up here of 80 comma 200. So it shouldn't matter because all those points lie on the line, which two you choose. Okay? Well, let's go ahead and use this formula here and go ahead and crank out a slope. I might be working a little backwards, but here, let this be x1, x2, y1, y2, and here we go. 150 minus 100. And you don't have to necessarily crank it out. And notice how I'm going to leave my answer in terms of a ratio. So 150 over 100 should be 50. And 70 minus 60 is 10. And if I reduce 50 over 10, it's just 5 over 1. Now, the meaning, since I'm talking about it, all I have to do is attach the units. 5 what over 1 what. You guys remember what 5 was? So let's go ahead and look. 5, now look at, here's height and weight. So y was the weight, and it's positive. So this means a person is going to gain 5 pounds for every inch on average. So there's the meaning. The chart shows or indicates the person will gain or go up, however you want to say it, 5 pounds for every inch. Now notice that's also possible or positive. So every inch increase in height. You get it? Now I've only done the slope part of it. That's not even to the end line yet. But remember, we just found my slope, or your slope. And we can go over here, y equals mx plus b. So we can take y equals 5x plus a b. And then all we have to do again is plug in any point. They'll all give you the same y-intercept. You could plug in the first one. And you know what? This time let's plug in the second one. 150 for y. And you can test me. Go ahead and plug in the other point on your own time and see if we get the same answer. So 150 equals, 350 plus a b minus 350 minus 350. So b here is going to equal, negative 200? So now I found my y-intercept. So my function, remember you have to write the final answer. This is like the end, 5x plus negative 200. Now, let's see if my calculations are right. 7 times 5, 5 times 70 is 350. And if I put 150 in here, they're both positive numbers. And when I subtract 350 to both sides, I have some function that looks like this. Okay? Now, here's the problem. What's that minus 200? In other words, if I'm 0 pounds, could it be minus 200? So something's going wrong. What possibly could be going wrong? Any ideas? You always got to look and kind of evaluate the variables you're getting. Go ahead and see if your points are right. So at 70, my pounds, I'd be 150. And at 60 pounds, I'd weigh 100. What do you think? So 150 minus, and check your math, minus 100 is 50. 70 minus 60 was 10. So that went in 5. Okay. And even if, and sometimes if your answer seems a bit odd, you could go ahead and plug in the other point like I was challenging you to do a second ago. Sorry, my calculator. Let me do a new share here. And let's do pins. Apologize, the computer's glitching on me again. See if I can get out of that mode. I don't know why that's happening. Let's see if we can, there we go. I'm sorry. So here's the pins again. So let's try plugging in another point, see if we get the same value. If we would have chosen, 100 here equals 5 times 60 plus a b. Notice what happens. This is 100 equals 300 plus a b minus 300 to both sides. Okay, so that's still the same answer. So what could possibly be wrong? And I'm going slow intentionally here, just trying to see if you can figure out how this applies to my function. Because, well, do I have a 0? Do I actually have this y-intercept on my function? The answer is going to pop out at you here in a second. So, what do you think? Anything? In other words, and I'll just kind of cut to the chase here. My graph is not representative, and this is what I was trying to indicate to from this frame of reference. My graph, if you weigh 0 pounds, for instance, you can always test, or 1 pound or 2 pounds. If I plugged in 10 pounds, right, because x is, I'm sorry, I shouldn't say that, the height. I totally misspoke. But for x, because it's a height, you could plug in what happens when you're 0 inches tall, and you, according to this, you would equal negative 200 pounds. So the model that you develop a lot of times will only apply for certain instances. So make sure that you account for that. Your answer is correct here, except it only only applies for people that are 60 inches from 5 feet tall all the way up to here. And it doesn't apply over here or over here before a height of 5 feet. So make sure you understand, and that's why they're talking about a frame of reference. You can say, and a lot of times you can say the domain will only apply for 60 less than or equal to x less than or equal to, what did we say, 83? I don't remember. Yeah, approximately. Notice from 60 here all the way to 83. So the reason I'm going so slow there, it might be real confusing. You can go back and listen to it again. But in other words, this problem only works, or no, only you can only make predictions on the weight. This is the best way to say it. You can only make predictions on the weight based on heights from 60 to 83. Okay? Likewise, the corresponding range, we can talk about that later too. So we already talked about the slope in the problem. What's the y-intercept? And in this case, no meaning. Because we already talked about it, 0 inches minus 200 pounds makes no sense. Sorry, don't know how to spell yet. Okay, so hopefully you're getting the gist of all that. Sometimes your problems and models will have answers, sometimes they will. Now, if I'm going to go ahead and hold true to my function here, and if that's my equation, we're almost done with this video, so hang tight. If you're going to use your equation, let's do part F there, to predict the ideal weight of a person 6 feet 5 inches and of a person who's 3 feet. First off, we can't use it to make a 3 feet tall prediction. We already said that because 3 feet, if you times that, because remember, you can't plug 3 into your problem. You'd have to plug it in inches, and 3 times 12 inches would be 36 feet. You couldn't plug that in and get a reliable answer. So that's already out. That's not reasonable. Now, in other words, what that tell care providers, you can only use it at certain times. And the only time, and I keep saying the same thing, is when the height or the inches are in this domain. So 6 feet 5 inches. Now, 6 times 12, well, we got to turn it into inches, so all our units are the same. It's 72 inches. So I'm just looking here, plus 5 more, right? So for 77 inches, if I wanted to use that model, 77 inches falls, let's use a different color, in this domain of answers. In other words, it's in if the function is only reliable for those heights, 60 inches to 83. So because it falls in there, you can use the model. And if you wanted to use the model, here's your function here. And let's use black this time. And let's see, make my pen a little thinner. You could say, here's y equals mx plus b. So for y, you're going to actually, now notice that's a height, so you're going to plug it in here. Oops, sorry. That's a little too thin. I don't even, gray, but I guess we'll just deal with the gray for right now. Your slope is, you should be yelling at me and say, hey, that's a 5 times 77 plus a b. Now, my b you do know, remember, I'm maybe getting tired. I don't know. I apologize. Trying to erase that. The computer's lagging again. Good time to stop. So in gray, now notice minus 200 is here. So y is going to equal, what is that, 35, and you can do it on a calculator if you want. Should be 385. Please go ahead and check me right now. Go ahead, I'll wait. So you should have 385 minus 200. And if you do that, your answer will turn out to be 185. And notice your answer, because it's y, will be in pounds. So it's a big deal not to know just the number, but actually what you're talking about. Meaning, here's a slope. It meant something in our problem. The y-intercept in this case had no meaning. And our final answer that they're asked about this, somebody that's 6'5", I'll ask you all of these questions, and hopefully you can communicate. And that's part of being in math and the class, is I'm trying to get you to be able to communicate what exactly is going on, not just say 185 puppies. So the answer I'm looking for part F is for a person of a height of 77 inches, that's the X, that their weight, as modeled by the picture, the graph, would be 185 pounds. And then as a second sentence, you can say the model does not apply for those that are 3 feet tall and therefore we can't use the model to predict anything. All right, hope that helps. You will see some homework questions on a different document, and I'll put that in the notes here too, in your assignment. So hopefully that was a good go at it. You've now made it through 3 videos. Good luck on the homework.